We're going to show an example of a research project utilizing our cloud computing testbed to investigate some of the resource allocation issues involved in sharing a distributed set of resources among applications and users. As shared computation resources become a commodity and grow in scale, deciding who gets which resources becomes a big problem. The demand for a resource may be bursty, and so the price users are willing to pay for a resource over time will also vary. Fixed price schemes suffer both from underutilization and demand truncation. Our approach is to provision a resource on a computation market where prices vary with demand. This market uses virtualization to provide performance isolation, fine-grained and agile user-exposed resource configuration control, and it allows users and applications to share the same infrastructure on demand. One application of our market-based cloud computing platform uses an image processing algorithm that transforms arbitrary photos and videos into cartoons. Our demo showcases 4 HP, Yahoo and Intel technologies. HP Labs Tacoon, a market-based resource allocator, HP Labs VideoTune, an image processing algorithm, Yahoo Hadoop, a distributed file system and programming model for cloud computing, and finally Intel VT virtualization technology. In our demo, we first configured a number of hosts and their memory and disk. We also specify how much we're willing to pay for our virtualized cluster through a spending rate. All of these variables can be changed at any point without interrupting running jobs. Increasing the spending rate will immediately increase the CPU share on the cluster nodes. The system both creates the virtual cluster and configures a Hadoop installation. The whole process takes less than 5 minutes. We can browse the distributed file system that will store our files. And here we've uploaded an MPEG video stream of a HP marketing video in a directory called video, which will serve as our input. The next step is to run our application. The video processing logic uses 3 Hadoop MapReduce jobs. The first one splits the video stream into substreams, the second one performs the transformation on a substream, and the third one joins the transformed video substreams into the original order. The performance bottleneck is in the transformation phase, which is why this stage is fully parallelized. The MapReduce jobs and the descriptor file specifying the order in which jobs should be piped are packaged in a cloud archive file. This archive file is all the platform needs to run the job. During the transformation phase, we can watch the stripped video streams as they are being processed. While the job is running, we can monitor its performance. This is based on the overall demand in the system as well as your own spending rate. The price dynamics of different resources, your capacity over time, and your spending history can all be easily monitored to determine whether reconfiguration is necessary. Once the join phase is complete, we can download and watch the resulting video stream. A new job can be submitted with different algorithm parameters if the result was not satisfactory, or alternatively individual pieces of videos could be processed with different parameters. In that sense, the platform allows both batch-like and more interactive processing. The key point is that the resources can be configured to meet the specific demand of the user at any time. To summarize, we're able to quickly test our resource allocation system at a large scale with real application deployments, solving real-world problems. And we invite other researchers to use the testbed as well for their projects.